Alright, so hi everyone, hope you are doing well. So I want to share this video about TxGemma. So I am not a expert on this and I'm learning it. So if you find anything useful, please share it with me. So you might ask, what is TxGemma? So TxGemma is a model that Google just um, created. It is like Gemini or let's say ChatGPT. However, the difference is that it is fine-tuned for therapeutic application. So for example, you can ask it questions related to drug toxicity, or let's say you can ask it whether a drug will be water soluble or it can cross the blood-brain barrier, things like this. So I am really excited on about using it. There are different ways you can use it. The simplest way is using a notebook, collab like this. So this is the official collab they share. This is called TxGemma Quick Start with Hugging Face. I will share the link with you. So you have to click and run the collab, and then after that you don't need to worry about this, but if you are curious, read them. So you have to do this steps. First, you have to create a Hugging Face account. So if you don't have a Hugging Face account, click here and create one. After that, you have to give access or get access to TxGemma. So you have to click here. In here, there will be a section that you have to press accept. After that, you will see this. You have been granted access to this model. So we are done here. Okay. The next step would be configuring a Hugging Face token. So we have to create a read access token for Hugging Face. So click here. Okay. So um, create a new token, then click read, give it a name, something like EX. This is actually the third time I'm doing it, something like that. Press create and then copy this. We are done here. So after that, you have to put the Hugging Face token in column. So you have to click this secret, and then inside here you have to in name write Hugging Face token. You don't need to enter the name you entered in Hugging Face. You need to enter this from here, Hugging Face token, and the value would be the value you copied from Hugging Face. So that's it. Click this to be on and then run this cell. That's it for here. You can close this. After that, you have to run this cell. So it will download something related to it. It will take something like 10 minutes. In here, you have to choose a model. So there are different models. So it starts from 2 billion to 27 billion. I think we can use only these three, and these 27s are so heavy that they can't run here. So keep it on 9 billion chat, press run. It will take something like 15 minutes, because there are lots of big files. So you can see there are many files that if you sum them, it will be something like 20 gigabytes. So after it is done, so there is a green checkbox here. Go run this, and then we will see, we will reach here. So this TxGemma model is using therapeutic data command, and therapeutic data command is like some set of standards that you use to use artificial intelligence or AI models in therapeutic science. I know that doesn't make any sense, so let's move on. So then you have to run this set. This is going to download some examples that you can use. So here I added these two lines. So after this download ended, the examples will be in here, TDC prompts JSON. And if you print it with this, you will see a very big file. There are lots of example questions in this. So the example they choose is blood-brain barrier. And if you search for this in the JSON file, so I printed it in here. So the example they are using is this one. So the instruction is answer the following question about drug properties. In the context, they give some context about blood-brain barrier. So what it is and what it do, things like that. And then we have A for does not cross the blood-brain barrier, and B for crosses blood-brain barrier. These ones are kind of static, so they will remain the same. However, these two are dynamic. That means they will change in this code. So this one is drug smile. And if you are not familiar with drug smile, it is like writing a molecule structure in a linear way. So something like this. This is a drug smile. So in here, in this code, they use this code to replace the example code. So they change this drug smile to this, and that's it. You can see it here. And then after that, you have to run it. When you run it, it will try to predict it. So you can see the answer is empty here, and then you will see a answer here. So in here, it predicted that the answer would be B, which means it is going to cross the blood-brain barrier. So the first application is this. You can use it for these situations. There is also a pipeline API. If you don't know what is a pipeline, don't worry. It is just a different way of running this. So you will get a similar result here. The next thing, which is really interesting, is asking questions. So it will be really similar to ChatGPT or Gemini. So in here, the only thing that you need to understand is this here. So in here, the first line you see it is TDC prompt, and TDC prompt is this. So this is the TDC prompt. The instruction, the context, question, our drug smile without the answer. So we use it here, and then we ask a question. So in here we ask, explain your reasoning based on the molecule structure. So we wanted to know if it is going to cross blood-brain barrier or not. So now we want to know what is the reasoning behind his answer. So you can change this to whatever you want. If after you run it, you will see this. So this is the same thing we had earlier. This is our answer. This is the user prompt which we give. So explain your reasoning based on the molecular structure. This is the same thing. And this is the reasoning. So it is saying basically for this smile, it is really a smile based on its charge groups, based on its lipophilicity and other things. It concluded that it is going to cross blood-brain barrier. And this last one is again running it with pipeline. So this is the same thing. And yes, that's it. So I hope this was useful. I'm sorry for the video quality. I tried to fix it, but I couldn't find any easy solution for it. So if you find anything interesting, please share it with me and have a good day.